All right, in this video, I'm going to cover chapter 4, section 4.1. Okay, so from chapter 4, we're going to study the inference statistic, but we need to learn the probability first. Okay, so inference statistic means that we use sample data to the approximate, but in statistic, they use term estimate to estimate the characteristic of the population. So it means that parameters of the parameters. Parameter means the what characteristic of population. For example, sample. I mean population, mean population, standard deviation, things like that. And then we're the to figure out how many the to figure out the what percentage we can trust the claim under the hypothesis. So we see in that these stuff in chapter what the later chapters. Okay, but chapter 4 we're going to focus on study probability. So probability is a chance that something will happen. You can see it in lecture the handout, right? So probability is a fraction or a decimal number between 0 and 1. So keep in mind this, we got when you got the probability and then you got a negative number or a number beyond the one, I mean less than negative number or beyond the one, that means you got something wrong. Okay, so probability must be positive number in the between 0 and 1. Okay, so it could be 0, could be 1. Okay, but it barely happened, so 0 and 1. Okay, so it should be most of cases between 0 and 1. Okay, so probability of impossible event is 0 and the probability of certain event is 1. It makes sense. And then if something has a probability of 0.05 or less, it's called the unusual. Remember that in our discrete statistic, we learn about significant low and high. If the data value is less than um, the x bar minus 2s or greater than x bar plus 2s, we say that the data value is significant low or high. Likewise here, if the probability is less than, I mean, the probability that something an event occurred is less than 0.05 or great less than 0.05, that we say that is unusual. Okay, so now then probability event A is denoted by P of A. What's the event, by the way? Event is the group of the or the subset of the outcomes what we are interested in. Okay, for example, when you yeah, we can talk about later, but when, for example, think about this, when you just draw a die, okay, so and then we expect that we're gonna get 1 through 6, right? 1 2 3 4 6 1 2 3 4 5 6, right? And then we want to figure out the probability that we get the even number, okay, 2 4 6. Okay, then now the set of, the 2 4 6, the set 2 4 6 are called the event. Okay, there was a probability that we get the even number when you draw a die. Okay, so then when you draw dice, then what then the probability that we get the even number going to be 3 over 6, which is a half, right? So now from that example, we use classical probability. I'm going to talk about this one later. Okay, so the probability that event A does not occur is denoted by PA. You see the bar? Is that is called the probability of not A. Okay, the round probability is to 3 significant digits. Okay, leading zeros are not significant. So now keep in mind this. And then now then example, you have 1 in a million chance of winning a lottery. Then probability that you win the lottery gonna be 1 over 1 million, right? So 0.0000. Okay. So now then there is an 80% chance of rain. This is a probability that rain will the it will be rain gonna be 0.8. And then in a coin toss, okay, we just tossing a coin and then you just toss a coin, then but a probability that you got head gonna be 1/2, right? Now, yeah, so the next one, in a multiple choice question with 5 choices, your probability of guessing the correct answer gonna be 1/2, which is 0.2. Okay, and the probability of guessing of the wrong answer gonna be p of correct bar, which means the probability of not what guessing the correct answer, which is 5 or 4, 4 over 5, okay, which is 0.8. So now let's see, you see the basic probability. So event is on any collection, result, or outcomes of procedure. So now a simple event is an outcome or an event that cannot be further broken down into simpler components. For example, so the example, the rolling, the the rolling a dice, and then what you can expect that 1, 2, 3, 4, 5, 6. Then each outcomes 1 through 6 cannot be broken further, right? So each outcome are called the what simple event. Okay. So now then the sample space for procedure consists of all possible simple event. Okay. Now then the let me see. Now we see sample space is can be is just nothing but a set of all possible outcomes, but each outcome must be simple event. Okay. This is the example right here. So in the following display, we use a B to denote the baby boy, and then G to denote a baby girl. Then see procedure single birth. Then example event can be one girl. I told you. What's event? Yeah, see, event is on any collection of result or outcomes of procedure, but I told you event is what I mean. The um the more accurate definition of event is what event is a subset of a simple space. Okay, I mean just group of the outcomes we are interested. So, for example, example event, we are interested in we wanna figure out probability that we I mean you know the certain the married couple has girl. Okay, then the that one outcome we can what there is only one outcome with the girl in the event. Okay, and then that girl, one girl, that outcome must be simple event because that outcome cannot be further broken. So now then sample space going to be what the complete list of simple event. So how many outcomes we expect in that in here, so baby a boy or a girl, right? So we expect only 2 outcomes in the sample space. So key minus, and then 3 birth. So yeah, so the marriage couple just have planned to have the 3 the babies. Okay, so then let's figure out probability that we have 2 boys and 1 girl. Okay, so then we what see that BBG or BGB and then GBB are all simple events resulting in 2 boys and 1 girl. So the each outcome consists of the 3 you know 3 consecutive the letter B or G, right? So then BBG and the BGB and then GBB must be a simple event, and then these 3 outcome set of these 3 outcome must be event. Okay, so now then what's the sample space? It's just just we want to figure out all the combination of B and G. Okay, 3 letters, continuous letter consisting of B and G. Okay, so B B B through the G G G. So these are simple event, and the set of these simple event must be sample space. Now, so the now simple event with 1 birth, the result of 1 girl is a simple event, and the result of 1 boy is another simple event. So that's so that's um, the solution of the first case, single birth. Okay, so but let me skip this PowerPoint slide. Okay, so now then next one, the 3 approaches. But keep in mind this, if you don't quite understand this one, so please read the PowerPoint lecture slide. Okay, keep in mind this. I strongly recommend that you read a textbook. Okay, and then the 2 before watching my lecture video, please read and list the PowerPoint lecture slide. Okay, so 3 approaches to finding probabilities. So relative frequency approximation and the classical approach and the subjective approach. So we're gonna use most of cases, we're gonna use classical approach. So what's the classical approach? Is the probability will be calculated by total number of outcomes in an event divided by total number of outcomes in sample space. Okay, so think about this. Find the p, roll a 2 with a 1 die. So we just roll die and then probability that we're gonna figure out probability of 2. And then well, how many outcomes in an event? 1, right? Okay, how many outcomes in a sample space? 6. You see that? Because how many items has value 2 when you roll die? Because roll die, then we expect 1 through 6, and then there is only one outcomes which has this number 2, right? The total outcomes event. In this case, event is what? Event is the set of all the outcomes whose value has 2. So how many outcomes in the event? 1. How many outcomes in sample space? 6. So 1/6. Define the draw on ace from the deck of a card. So I think of 52, total number of cards is 52, right? And then how many aces in the card? And 4, right? So 4 over 52. That's gonna be the probability. So see that classical probability means that the probability will be calculated by total number of outcomes event divided by total number of outcomes sample space. And the relative frequency approximation is the we the do experiment repeatedly. Okay, we survey repeatedly. So for example, so estimate P of NG students has brown eyes. So now then we're gonna observe each students whether or not students has brown eyes. So yes or no. We have only 2 outcomes, right? So then we're gonna count the number of times students has brown eyes divided by total number of students we observed or we asked. Okay, so we use a relative frequency approximation to compute the probability of the outcome then we by observing something or surveying or experiment repeatedly. Okay, so a subjective approach, probability A is estimated using knowledge of the circumstances. So yeah, that's the end of this course. So we're not gonna talk about this one okay in deeply, but example is this probability that it will rain. So it's not, that's definitely the subject to calculate, to figure out the probability it will rain. We cannot figure out by that relative frequency approximation or classical approach. We just use the some information from the circumstance. Okay, so now next one. Mm, by the way, in the classical approach to probability, so here we assume that, see that when using classical approach, we always confirm that the outcomes are equally likely. So for example, when you roll die and then what we assume that each outcomes are equally likely, right? Let's keep in mind this. And then the now you see rounding probability. When expressing the value of probability, either give the exact fraction or decimal or round off final decimal result to 3 significant digits. Okay, keep in mind this. So suggestion, when a probability is not a simple fraction such as 2/3 or 5/9, express it as decimal so that the number can be better understood. Keep in mind this, and up to 3 decimal result. Okay, so law of large number. As a procedure is repeated many times, relative frequency approaches the actual probability. What that means? So you see here, for example, in 10 coins tosses, you might not get 5 tail 5 head. You apply using the classical probability, we're gonna get a probability of head gonna be one half, right? Probability of tail gonna be one half. But when you use the relative frequency approach, so we just tossing a coin 10 times, and then the calculate the probability of head may not you may not get five tail or five head, right? But if you just increase the number of experiment up to 10 times, you're just tossing a coin 10 times, then you should get close to five tail and five head. Okay, so since the so that the the probability obtained by relative frequency approach to what the probability obtained by classical probability, right? So that's the law of large number. So now then, mm, next one, identify significant result with a probability. So, okay, the rare event rule for inference statistic. If under given assumption, the probability of a particular observed event is very small and the observed event occurs significantly less than or significantly greater than what we typically expect with the assumption. So we conclude that the assumption is probably not correct. And then so now see, give me a second. So using probability to determine when results are significantly high or significantly low. So I told you if probability of something is less than or equals 0.05, then we say the probability significantly low. Okay. Okay. And then see significantly high number of successes, X successes among n trials is a significantly high number of successes if the probability of X or more successes is unlikely with a probability of 0.05 or less. That is X is significantly high number of successes if probably X or more is less than or equals 0.05. Okay, so and then using the probability of the significantly low number of successes, if X successes among n trial is significantly low number of successes, if the probability of X or fewer successes is unlikely with a probability of 0.05 or less. Okay, so when you, for example, when you're tossing a coin, okay, and then you got a head, um, what not that's not the appropriate example. I think we see example. Oh yeah, example here. In a survey, 169 respondents say that they never use a credit card, and then excuse me, 1,227 say that they use it sometimes, and then 2,834 say that they use it frequently. So would it be unusual to find someone who never used a credit card? So then we're gonna figure out the what? We're gonna find the probability what of probability that people never use a credit card. So using the classical probability, right? It's 169 divided by total number of the respondent, which is 169 plus 1227 plus 2834. So here 169 divided by right 169 plus 1227 and then plus 2834. Okay, so that's going to be approximately 0.04. 0.04. So this is less than or equals 0.05, right? Okay, so it's unusual. Okay, so now that means significantly low, right? In the example, the table below lists a result from pre-employment drug screening test. So if one of the subject is randomly selected, so since randomly selected, so it means that what we assume that each outcome is equally likely. Okay, so find the probability that person used drug. Okay, then what? The definitely we apply the what classical approach, right? Probability. I mean, so how many person use drug? So 44 plus 6, right? I mean 44 plus 6. Okay, so 44 plus 6. Okay, divided by. Okay, and then total number of the well, the person. Okay, so received screen test. So we see 44 plus 6 plus 90 and plus 860. Okay, that's probability the person used drug. And then find the probability the person does not use drug. So then, what? Here, think about this. In all the total number of persons, some of them use drug. That means what? And I mean, so we, you know, let me calculate this. This is a probability that is what? Probability that a person uses drug, right? Equal this. So that's gonna be, let me calculate the probability. So I got 0.05, right? I got 0.05. Okay, so it's significantly low, right? By the way, so then what's the probability that does not use drug? That's gonna be P person not use drug. It's gonna be what? Because we have only two, expect two outcomes, right? Use drug and not no drug, right? So this is gonna be 1 minus probability person use drug. We can calculate that one. It's like this 1 because 1 is what? 1 means the sum of all the probability. Keep in mind this under the experiment, okay? So sum of all probability must be equal to 1, okay? Right? So keep in mind this. So that means that what? 1 minus, in this case, 1 minus probability the person use drug gonna be equal to probability that person does not use drug. Because we expect only two outcomes: use drug, not use drug, doesn't use drug, right? Okay. So I know. So we just ignore the positive test result, negative test result. We ignore those two. The we don't concern those two. We just ignore those two cases. Okay. So we got this one. This is going to be 1 minus 0.05, which is the 0.95, right? Okay. Now next, find the probability the person got a false negative test. Okay. Test indicate the that means a false negative test result means that test indicate what? They did not use drug. They did not use drug. That's what we that's the meaning of negative test result, right? But this is false. It means that what? The test result is wrong. It means that what? They actually use drug. Okay. So now that what? Then let's see. Here I need to look at the numbers. Give me a second. All right, here. So you see that here, 6. Okay. Um, this number of persons actually use drug, but they got negative test result. Okay, so it means that the test indicated they did not use drug, but actually they did. So that's 6 means first negative. Okay, first negative test result. What about the what? This one, 90 students, 90 person. So these students, the persons, no, they don't use drug, but got positive test result. So this is what? First positive test result. Okay, see that? Okay. So now we want to find out in this question, we want to find out what probability the person got a first negative test result. So it should be what? 6 over the sum of them. It should be what 1000, right? Because 44 plus 6 plus 90 plus 860, which means the total number of outcomes in a sample space going to be 1000. Right? Okay. So now then that's going to be 0.006. Okay. And then what about the this next question? Find the probability the person got a first positive test, which is this. Okay. So even though the person didn't use drug, but the test indicate that they use. Okay. So that's going to be 90 divided 1000. Okay. So here there's a probability that false negative. Here the probability that false positive test result. So which is a 0.9, right? 0.09. Sorry. It's going to be 0.09. Okay. So now example, each of the, by the way, in this case, 0.006, so which is less than or equals 0.05. So this is significantly low, right? Okay, and then example, each of the two parents has a, a genotype, the brown, blue, and then which consists of a pair of the alleles that determine eye color, and then each parent contribute one of those alleles to a child. If the child has at least one brown allele, and then the color will dominate, and the child will have brown eyes. So eye color is actually somewhat more complicated, but we just made it simple. Okay. So what is the probability the child of these parents will have blue eyes? So let's figure out that. Let's figure out the sample space first. Okay. So then we expect the sample space. Then we expect the so you see that here each parent has the which has genotype brown or blue, which consists of the pair of the allele that determine eye color, right? So then one from the, if child has at least one brown allele, then so example for I'm sorry. So each parent contribute the one of those allele to a child. So the child will receive the one allele from the two one allele from each parent, right? So we say that we can expect that, let's say R means brown, L means blue, okay? Say starting from RR, okay? And then RL, the LR, and then LR, you see? So that's all the possible outcomes, right? Okay. So now then, if the child has at least one brown allele, then that color will dominate, and then child will have brown eyes. So we're gonna find out then here, we're gonna find out what outcomes containing at least the one brown allele, right? That's gonna be event. So here event is gonna be RR and the RL and the LR, because we wanna we're interested in the pair of allele containing at least one brown allele, right? Okay, so because what's the probability that child of these parents will have blue eye? I'm sorry, I just confused the question. Blue eye. So that should be LL. Okay. So here we are interested in the pair of allele does not contain brown allele. So only one outcomes should be in the event, which is LL. So now probability that what blue eye, okay, it's gonna be one of total number of outcomes in event divided by total number of outcomes sample space 4. So which is 0.25. Okay. So now that's the section 4.1. I just introduced the probability and the concept of probability, and then a couple of several these terminologies, concept and terminologies of probability. Okay, next time we're gonna study addition rule and the multiplication rule in probability. Okay, let me stop here.